Good morning, everybody, and welcome to another beautiful Science Saturday. I am in a brand new location, which is exciting because it is always exciting. I've got the ocean behind me. I've got some very fancy science going on around me. But first, I want to take a minute and thank everybody because today is Science Saturday's 8-year anniversary. Now, I know what you guys are all thinking, but Kitty, you can't possibly have been doing this for 8 years. You look so young. I do, I know. But it's been so much fun, and having 8 years of community interactions and talking with scientists and chocolate makers and the range of things that we have done is absolutely amazing. I'm not going to tell you about it because you guys are going to go back and watch all the videos to find out what we've been doing for 8 years. We started in person at Lattes in Paradise, which, yes, I do miss my coffee with Science Saturday every morning, but don't worry. I still had my coffee, as you guys can probably always tell. But this has been so much fun and learning and changing with the technology. Obviously, it was a big change when I got my fuzzy mic. I know it was very exciting for everyone to be able to hear me better. But thank you all for being with me for 8 years. So now, today, we are on St. Thomas, and we are out on Cokie Point, and I am joined by some top-notch scientists who are going to join me right now. Come on over, guys. So, the question of the day, who are you, where are you, why are you?
Hi, my name is Andrew McGregor. I'm a conservation manager here at the Coral World Ocean and Reef Initiative. We are a 501c3 nonprofit that focuses on all things conservation here in the U.S. Virgin Islands, from coral restoration to animal rehab to marine debris collection and kind of anything, any sort of like terrestrial recovery as well. And I'll introduce my other colleague here.
I'm loving the fuzzy mic. I'm all about this.
Hi,
my name's Kelsey. I'm the education and outreach coordinator here at CWORI. Been on island since 2008. Both Andrew and I went to the University of the Virgin Islands, so shout out to them. And have transitioned from Coral World over to CWORI just in the last month, and really excited to be a part of all the cool things we got going on over here at CWORI. Like Andrew mentioned, our coral restoration projects. We've got a lot of rehab things going on with local seabirds and sea turtles, and just really excited to get people excited about science. So we're super happy to have Kitty on board today.
Yay, amazing. Thank you, guys. So, all things conservation. That's a pretty broad goal, but today we are in a specific area of your research and restoration. So what is this area? Where are we?
So this is what we call our coral reef pad, so to speak, for lack of a better term. But here we have 16 open flow through raceways. Each of them are 120 gallons each, and this is where we house a lot of the coral fragments that are used for our coral restoration. So within the conservation department here at CWORI, we have 3 separate projects that are geared toward restoring reefs here on St. Thomas and in St. John in the USVI. And we aside from this kind of location, we also have what we refer to as our in-water coral nursery, where we also house corals in a similar fashion, just in a more like open, natural type system.
All right, cool. And so we're starting here, and I heard you guys have some newly collected coral. What's going on? Who are we talking to? And who is this handsome guy in the corner right here? What is your name?
I'm going to get him his snacks.
Starting with the coral restoration aspect, we do our restoration in kind of 4 distinct stages, as I like to think about it.
Okay.
The first stage is the collection process. That involves us going out to different sites and locations around St. Thomas and St. John. We collect parts of wild coral colonies. We bring that material back into our nursery. to then further propagate it and use it for our outplanting and like our restoration.
Okay. Propagate is going to be one of our vocab words for the day. What does propagate mean?
Propagate is, on a technical term, is either sexually or asexually creating more of whatever you have. And so in this case, we are asexually taking our corals, we call fragmentation. We cut them up into small little pieces, increase the numbers of this kind of specific coral.
Okay.
And then in doing that process, corals actually grow a lot quicker when they're bisected or fragmented out. And so we hope to be able to kind of increase the amount of that putative genotype or that specific coral colony that we collected from, and then be able to kind of reintroduce that colony to a different location where we're trying to restore.
Okay, so that is really cool.
So these are some large pieces here. I'm going to hold up this Montastria cavernosa. This is a piece that we collected two days ago.
Okay.
And this process really involves just taking a hammer and chisel. I have those tools on the desk over there that I'll show in a sec, but we, as safely and minimally invasive as possible, try to remove chunks of coral from the wild colony. As little amount as possible. We do want to preserve as much of that colony that's on the reef so it can continue to grow and thrive. And then we bring that material back. We let it kind of sit in our raceways for a couple of weeks just to let it recover from any stressful events that might happen in that kind of collection process. And then we move to our propagation stage, which is our second stage, where we actually fragment this out and try to increase kind of the quantity of corals that we have from this colony.
And I mean, honestly, they look pretty happy.
Yeah.
Also, not what we're talking about today, but I love being able to see how the coral grows. You can see like the white skeletal structure pretty much of how it grows up, and then you have the living tissue on top. We have done a few Science Saturdays based around coral, and so I just wanted to point that out, that this is something that we have learned a little bit about in the past, and I don't remember which video it was on, so we're gonna have to watch all of them to remember. But really cool to see kind of this stage. Also, this crab obviously wants to be my best friend.
Well, I did bring him some snacks. So although these guys, we have our crabs in here primarily to eat algae. We are also breeding our crabs and our diadema, our long spine sea urchins, because there's a lot of hypotheses and theories about the importance of our herbivores in terms of coral restoration and things like that. So we have these guys in here, but my favorite thing to do is to watch them go. Very, very excited when we offer them a piece of fish. Of course, he's not going to do it because, oh gosh, and try not to get my fingers in the process.
Oh my goodness, look at it.
So yeah, so these crabs are also a really important part of a marine ecosystem. Everything is interconnected. So not only, obviously, we have the focus, obviously, on our coral reef restoration programs, but things like our invertebrates are a super vital part of the ecosystem as well. And without them, then we get too much algae overgrowth on our corals, and the whole ecosystem can fall apart. So, obviously we have things like climate change, warming ocean temperatures that are affecting our corals very deeply. Unfortunately, here in the Virgin Islands, we've had some really catastrophic bleaching events the past few years. But, it's not all doom and gloom. There's lots of things that all of us can do to help, whether it's making sure we're using reef safe sunscreen, making sure we're not touching corals. A lot of people confuse them for rocks when they're out kind of snorkeling, scuba diving, things like that. And obviously taking lots of pictures of our little cute
when
crabs.
Andrew picked up the coral, it was from the side. No live tissue was touched.
He was watching his coral handling techniques. See if these guys want a little fishy as well.
So this is really cool. So all of those threats to our, not just coral reefs, but our ocean health in general, this is something that you guys are doing to help with it, which obviously feeding the crabs is the most entertaining part. But we're going to stay focused. I'm going to stay focused. I'm never focused. Oh my goodness, he's so cute. He finished the whole fish. And now he's just like, they're preening his little, I don't know what those are called.
Just to piggyback off Kelsey, our hopes are to kind of reintroduce these invertebrates or increase the density of these invertebrates on our restoration areas to help mitigate that increased growth in algae. So we're trying to breed channel clean crabs and then the Diadema antillarum, the long spine sea urchins, and produce juveniles of both of those invertebrates out onto the reef, and hopefully they'll help consume the algae that competes with these corals and give a more suitable environment for our restoration efforts to continue to grow and stuff.
So I have it on good authority that you guys have been funded for some urchin restoration for the next few years, because it was us. I'm so excited. But I've been promised baby urchins, and this second it starts, I'm going to come barreling through this parking lot to come play with the baby urchins, which some people might think sounds ridiculous because urchins are known to be a little scary on the reef, if you accidentally step on one. However, baby urchins are one of the cutest things in the entire world, and I'm so excited. And when that happens, we're going to do another Science Saturday just on me giggling, possibly, which is scientific. But we're going to continue. So, where are we going next?
So, on to stage 2 of our restoration process. Once we have these corals in here, we wait a couple of weeks, and then we go into that fragmentation process. So what we call fragging and propagating is kind of that second stage, and we'll kind of walk through that now. So
all right.
We've actually have some corals that we also collected a few weeks ago that are getting close to to that kind of propagation stage. We have some Orbicella favulata here that I will go through the process of fragmenting.
They're so happy.
They are. They're so cute. Okay, can you say their name one more time?
Yep. So this species of coral is Orbicella favulata.
Orbicella favulata.
It's a type of bouldering species of coral that we have here. One of the more prominent Orbicella species that we have around the territory. Okay. So I'm going to bring these fragments over to our bandsaw.
Sounds scary. Let's do it.
The first time I used it, I did have to ask multiple times if I caught my finger, what happened. And then, fortunately, one of the very brave coral techs stuck her finger and was like, nothing happens. You're all good. How it saws through the corals is impressive because it doesn't actually do anything to you if you accidentally get your finger in there.
I will not be testing this theory. My fingers are safely on Fuzzy Mike. Okay.
So a brief breakdown of the bandsaw. We use a diamond kind of plated blade, so it's not like your typical saw blade. So there's actually no teeth or serrated edges on this. It's just a bunch of small diamond little granules on the end of this blade, and that is what is going to actually be cutting through that coral skeleton and the tissue to break up these pieces.
Okay, so serious question. Do you wear the diamond plated saw as a bracelet?
You could. I think it would look pretty fashionable, but we don't. Those things are a little too expensive for me to be wearing around as a fashion statement.
Fair.
But I like the idea.
Responsible spending.
Exactly.
Right here.
Exactly.
Not jewelry.
Mm-hmm. So I'll go through, I'll take each of these pieces, I'll cut them up, and then I'll be placing them on what we call our coral plugs. This is just a substrate that we put the fragment onto, and it allows us to orient the polyps in the right position, keep them stable as they continue to grow out and grow into that outplanting size, so to speak. Another substrate that we can put the corals on are what we call our coral pucks. They're just a little bit larger, made out of the same kind of concrete-like material. It's just a bigger surface area for larger fragments of
so
coral.
we've got options. We have little stools, we have bigger tables.
Exactly. We'll get into, a lot of times these pucks are what we use to store the corals on when they go down into our in-water nursery. I have some pictures to show kind of what they look like in real time, and we'll get to those in just a little bit.
All right.
So I'll go through the process here of fragmenting one of these corals out.
I'm not scared. You're scared.
It does get a little bit messy and is a little bit tedious, but it's pretty cool how quickly it kind of just goes right through them.
So the main goal is to be, as minimally invasive as possible. So we try to do this process efficiently to reduce the stress that gets put on the piece of coral itself.
crazy. All right. I'm kind of at a loss for words right now, which is weird. And full disclosure, I've seen this happen before years ago, but it still just kind of blows my mind. So, coral or alive, coral are a combination of plant and animal. However, because of the careful nature and how this is being done, it's helping the coral.
Yeah, it's kind of like a really crazy concept to think about, because when you think about an animal, right, and when you're separating pieces of an animal, you're like, well, that can't be beneficial for it. But for corals, it's really extremely beneficial. And as Andrew was mentioning before, with, fragmenting the corals and them growing exponentially faster, it's, for me, being new to the coral world, I have found this process extremely fascinating, because most of my experience before working with corals was, with the quote unquote charismatic megafauna. Right. So, the big guys, and you think about severing a limb or separating a colony of those types of animals, and you're
traumatizing.
Like, exactly. So it's been really cool to be a part of this, get to fragment them and then watch them grow in real time, I think is the craziest part about it. We have some corals that we brought in a month ago that have grown almost all the way over their puck. Wow. Which is pretty impressive. And then, obviously being able to be a part of outplanting those back onto the reef is really special as well. Because coral grows so slowly in its natural environment.
Growing up, you hear about, these giant corals that have taken thousands of years, and they famously grow quite slowly. But this kind of, short process is able to make them grow so much faster, which is really cool and so helpful for restoration process. Which of course we wouldn't need to restore coral if we hadn't have destroyed the earth in the first place.
There is that minor detail.
That's on us. But it's amazing that there's the science and the technology to know that this works.
Well, and that there's, I think the other part that, sometimes we think, oh, we're here in the Virgin Islands, we're small, we're, separated from all of these other coral scientists and people doing restoration work, but there are hundreds, thousands of people dedicated to this craft and this science, and it's just really special to get to be a part of that, and get people really excited about it too is super fun.
Yeah, this is exciting. So, Andrew, what is the material that you're using to attach the coral?
So this is just 2-part marine safe epoxy. It's commonly safe. Marine safe. There's industrial uses for epoxy as well, but this stuff is suitable to be put, in the environment and safe to use on corals and coral skeleton. We try to avoid applying and smothering the tissue part of the coral with this stuff, so we try to just focus on embedding the skeleton into this epoxy. But this is what holds the corals to this plug right here. And then over time, that coral, as that tissue continues to grow, it will skin over this epoxy and be able to grow over top of it. And then eventually, and we'll get to those plugs over there in Raceway 5, you won't even be able to see the epoxy anymore, and basically you just kind of get smothered by the coral tissue itself.
Okay, that's really interesting. So I've also noticed, as you've been handling the plugs, there's writing on the bottom of them. What is that?
So this is how we identify each of the fragments or the corals that we have in our care.
Data. I love data.
Science.
Data.
So there's 3 kind of key pieces of information that we have on all of our IDs of our corals. The first is the location. So these were actually collected from Ditliff Point on the south side of St. John, near Fish Bay area. So we just have a 4-letter kind of abbreviation of that site name. We have a species code, so Orbicella favulata, denoted as OFAV, and then we have a specific number, and this number is a 3-digit number that actually refers to the tag that we place out when we collect from a certain colony. So if you're ever out in the water we collected from, and we tend to put this ID number at the parent colony so we know where exactly all of these corals came from. And if we go back and visit that same
Scientists.
location, we can check on where we got it from. So
That's really cool.
so this number on here refers to the number that's on the tag, and we
Okay.
kind of continue that ID throughout the entire process
Okay.
from collection to outplanting.
That's really cool. I do love data, like a ridiculous amount, and I love like the connection between knowing where the coral comes from and then seeing how the fragments fare. That's really fun.
Exactly.
Okay.
And then given the face of climate change, and we've had the two bleaching events over the last 2 years, it's important for us to not only focus on what we're putting on the reef, but like what we're collecting from as well. So we do
Right.
go back to these parent colonies that we have collected from in the past, check on how they're faring throughout kind of this adverse climate that we're going through, and focusing on those as well.
All right.
So this is kind of, without just going through the entire process, these are kind of what our two plugs look like. The goal is to allow for this tissue on top to skin over the side of the skeleton and embed over the puck, and then once this tissue kind of reaches the edges of this puck right here, that's roughly 3+ centimeters kind of in diameter, that is our kind of target size to be outplanted on the reef. So I'll bring these corals back over to our raceway over here.
To the raceway. We're going to the raceway.
And I sit them back down on the tray, and we just let them either grow in our land-based nursery, or we can transport these corals down to our in-water nursery, and we'll do that for all of these pieces of coral that we collected from.
Okay, so spoiler alert, coral scientist actually construction.
Oh
Yeah, we do.
Yeah, you don't realize that when you get into these conservation-y fields, that you really are a jack of all trades in so many ways. Like Andrew and I were like replumbing one of the raceways the other day, and doing things like that you're like, oh, I want to be in conservation, but then you develop all these other skills that are handyman and construction and all this stuff too, that is fun as well, to be able to do those types of things.
Nice. See, this is what scientists look like. Today is World Women's Day.
It is International Women's Day.
Yeah, it's not World
Cheers
Women
to
in
us.
Science, but here's to the women. Sorry, Andrew.
Sorry, Andrew.
All good.
Sorry,
I'm
we
so-
forgot
I'm so
Andrew was here
supportive.
for a second.
Awkward. All right.
Something else that I think is important, Andrew, that you haven't talked about, and I can't explain it probably as well as you can, but the fact that all of these fragments are related to one another. So when you're fragmenting them, you're obviously asexually reproducing them. So we're creating copies when we talk about the genotypes. But then when we outplant them, how do we outplant them in a way that we make sure that they're also having the opportunity to sexually reproduce as well?
Definitely. That's a great question. So once these corals reach kind of what we call our outplanting size, which is kind of like what these ones right here are, the Montastria
That guy's
cavernosa.
They look so
These ones in this,
good.
you can see that a lot of the tissue
Those
has
cuties.
expanded out to the majority of the plug.
Look at that one. Oh my goodness.
Yeah.
That's my favorite.
I know.
A lot of the
No, that one. They're so cute.
A lot
Sorry,
of the, no,
Andrew.
you're all good. It's super cool and fascinating. A lot of the polyps have continued to skin over, and then once they reach this size, that's when we can take them out to the reef, cluster them together, and allow them to continue that fusion process and build up into a larger coral colony.
Okay, so we are not scuba diving today. I'm not dressed for it, but I heard you have some pictures for us.
Yes, I do have some pictures of kind of that process.
Cool. Ooh, scuba diving. Question of the day: are you for scuba today?
So if we were imagining us outplanting those corals on the reef here, we take a big glob of cement and we stick all of those little plugs in the cement like this. Imagine if these had corals on them. And then over time, each of these, as the tissue continues to grow, they'll fuse into one another, and then in theory will create this kind of larger piece of coral.
Okay.
That will...
But we have to make sure, right, that they're the same genotype.
Exactly.
Otherwise, they get... Yeah, it's like...
Yeah.
That's my
over-
scientific
They're
answer.
fighting over the Netflix password. They're not paying rent on time. All sorts of things go bad.
Right.
that way.
Corals do fight.
Yeah.
Actually, is it the beginning of Chasing Coral? They talk a little bit about like the competition of corals and the tanks.
Exactly.
All right, so we are imagining we are out on the under the water with our scuba tank. So what's happening here?
So to backtrack a little bit, this is one of our interns over the summer who is working on the corals that we have in our in-water nursery. So we have these tables built out of rebar that have and house all of our corals on them. This is another picture of Jessica Michael, one of our other technicians here. And so these rebar tables are designed to house these pucks. So that's one of the structures that we can actually hold corals in our nursery. And then we also have these, this is just another image of that fusion process. So this would be 4 separate plugs placed on one of these pucks, and then in theory, they'll fuse together and create one larger coral.
Cool.
Just another example of kind of those corals and that tissue
So
kind of
this is
fusing.
essentially a raised garden bed, like out in the ocean.
Exactly. We're trying to kind of put a bunch of these small micro gardening beds out to help these corals kind of continue to populate and grow on the reef. So then this is the other structure that we have in our nursery. This is what we refer to as a coral tree. We just instead of putting those corals on one of these pucks or the plugs, we suspend them from a PVC structure, and we've found out that our acroporid species, so our Acropora cervicornis, the staghorn coral, or the Acropora palmata, commonly referred to as the elkhorn coral, grow better and faster when they are placed on this type of structure.
Okay.
So that's why we have them suspended from the tree.
So they're happy there.
They're happy in that environment.
Nice. Ooh.
So this is just another picture
Very cool.
of our staghorn coral.
And these trees are right off of your facility here?
Yep.
In the open ocean?
Definitely, yep. They're right here along the Cokie Point Reef. And it's conveniently located because we have 2 of our restoration projects our outplanting areas in our restoration efforts are going to be on Cokie Reef. So that's part of the larger USVI Coral Reef Restoration Plan, a territorial-wide initiative where a bunch of different agencies and coral restoration practitioners are devoted to restoring these kind of critical reefs around the territory. And CWORI was assigned and has taken on the challenge to restore Cokie.
Wow, that's really cool. So if you're not a coral scientist, you can pretend that you are for a day. Don't touch the trees. Yeah. But if you're out snorkeling, you can just snorkel by and see them? Or so they're inside a protected area?
They're inside the buoy line of like where Coral World's like underwater observatory is. But if you come to Coral World and go to the underwater observatory on a really nice visibility day, you can actually see them through the windows. And you can even see them from like the walkway.
Okay.
So that's really cool. So even but something that we will talk about when you come back on another Science Saturday is the fact that we just opened a dive shop. So in addition to obviously getting people, excited about corals and things, now we're going to be able to certify people to become scuba divers with a conservation focus. So we're really excited about that as well.
Very cool. And here's another picture of some outplanting going on. Got a nice healthy coral who has a name.
Yep, so this is...
My friends are so embarrassed at me.
Porites is the species names of this coral. It's a type of finger coral. And we have taken these plugs that have grown up over time from a small little fragment to this size, and then we can either take cement, or in this case we took just a little bit of that same marine grade epoxy and attached that coral to the reef out here at Cokie. So this same location is just right down there.
Okay, and so the idea is that that epoxy is not permanent because the coral just grows over.
Yep.
And so it takes over from there.
Exactly. Once the tissue kind of skins over onto the reef itself, that's how the coral continues to cement itself, and it'll integrate itself onto that reef structure.
All right, that's really cool.
The last little portion that I wanted to hit on, we have a few more minutes here, is just how we monitor the success of our restoration. So I think a big critical thing is to not only get corals out on the reef, but to make sure you're doing it in a way that rebuilds that reef community over time.
Right, data.
Exactly. So we do that by taking large-scale images of the reef, and can then using different software, ID the corals from those images and track their growth and their surface area throughout time.
Cool.
So this is the interface of Tag Lab. That's the name of the software that we can do that kind of processing on. And then I'll shuffle through some of the slides. So this is actually an example of some of the fragments that we have outplanted on the reef. For these ones, this was July of last year, so this is before we had any outplants. This is just a general baseline image of what the reef was. And then we outplant 10 or so frags of one of our coral types. We give it another little ID tag right down there. So that's what that kind of mound of cement with our coral fragments in looking back.
And we're back. We lost cell phone service for 1 second. We're good. All right, so, and the app puts those numbers on, and you can keep track of all of that. This is really cool and fancy. Yeah. And looks really fun. I'm a little bit jealous.
It's a very convenient way for us to track a lot of the outplants that we put out over time. And it's kind of hard to see the numbers, but we have the same ID numbers on each of the individual fragments, and we can continue to track over time. We do these kind of photo mosaics or these large area images monthly, and we can then track the growth of all of these corals. And so the last photo mosaic that we got was of this past month, and you can see that from the small, you can see kind of on these leading edges of the tissue that these corals are continuing to grow and expand over the reef. Orbicellas are a slow growing species, and so it will take a couple of years before those polyps can fuse up into one large coral. But so far it looks like that kind of clusters off to a relatively good start.
That is really cool, and this is all really exciting work. This has been really fun. Yeah. So what oh man, so what do you, if somebody watches this and remembers one thing, start low expectations, like what you want somebody to remember about what we talked about today? I want everybody to remember how cute the crab was eating the little thing. So,
I don't know. I think that's such a great question. I think as somebody who has always been really passionate about the oceans, but maybe not a quote unquote coral person, I think that remembering that everything is interconnected, I think is such an important part. Like, whether it's what you're buying at the grocery store or what you feed your dog or what car you drive, like all of us are connected, and we're interconnected to the oceans, we're interconnected to, people in different countries going through different things. And, that coral reef restoration is so important to everyone and every ecosystem, I think is, the big thing. And corals can be cute too.
Adorable. Did you see those little polyps out? Jazz hands.
So yeah, I think that's like, for me, the biggest takeaway as being somebody, like I said, who's not maybe like a quote unquote coral person, but, loves to go to the beach and, loves to scuba dive and things like that, everything's interconnected, and making one little different change in your everyday life can make us really positive impact on your local ecosystem.
Yeah, absolutely. Okay. What about you, Andrew?
I agree with that wholeheartedly. I would also like to add that coral restoration is a very challenging process, but super important. I mean, given the fact that over the last 2 years we've had mass bleaching events that have contributed to a huge amount of die-off of these animals in the wild. And so I think it's critical that we continue this process and everyone tries their absolute best to just increase the amount of corals that we have around the territory. And we're not the only practitioners that do that. There's various organizations on St. Thomas, St. John, and on St. Croix that do that. And it is a super team effort for everyone to be able to do this. So CWORI can't do this alone, and we're just part of this larger initiative that the territory is taking on.
Nice. I would like to add to my answer, be nice to coral scientists, because sometimes you go out there and they're all dead. Not the coral scientists.
Oh God.
Yeah,
no. That too.
Woo! Sometimes there's a mass bleaching and all the coral in an area are bleached or have died, and it's really, really hard work.
Yeah.
So as much as we had so much fun today, it is really amazing and important science, and you guys are doing an amazing job. So I want all of you guys, my 8-year Science Saturday fans, I'm sure there are some of you who have been with me from the beginning, think about the coral, think about how connected it all is, and think about how important all this work is that everybody's doing. So we're going to wrap it up. The end of our 8-year anniversary. Thank you guys all so much for hanging out with us at the Coral Restoration Pad.
Affectionately referred to as the pad.
The pad. Live from the pad. We are signing off. Everyone, have an amazing weekend. Enjoy the weather. Enjoy the water. I will see you next month. I don't know where. I don't know why. But I will be here with Fuzzy Mike. See you later.